Hi all, in this video we will look into the problems for sum of product and product of sum with k map for three variables. Before moving into the problem, let us just recall that if the Boolean expression is been given to you in a symbolic form, either in terms of summation small m or product capital M, we know that summation small m is been denoted or represented by min term, and min term is nothing but sum of product. And also, if the function value gives me 1, then that represents my SOP, that is sum of product. And so we put 1 in our K-map designing. In the same way, if we happen to see a Boolean expression which has been represented by product of capital M, we represent that by max term, and we also name it as product of sum or POS. So if in the function value gives me 0, then that represents my product of sum. So we put 0 in K-map designing. So now let us solve or simplify a Boolean function using K-map in SOP and POS forms and implement with gates for the Boolean expression f of a, b, c to be summation m of 0, 2, 3, 4, 5, 6. So here it is to be observed that what is given to me here is in the form of my min term. So it represents my sum of product. And also it is evident from the question itself that the number of variables are 3 variables. So 2 to the power 3 gives me 8. So the K map has to be designed with the K blocks or 8 blocks. So now let us design our K map for 3 variable. For that, my K map will have 2 rows and 4 columns, and it is been constructed in this way. 1, 2, 3, 4 columns and 2 rows. So I represent this by my A and this by the 2 variable B and C. And what are the 2 possible combinations possible with a single variable A is nothing but 0 and 1. Here the possible combinations with the difference of 1 bit is 0, 0, 0, 1, 1, 0, 1, 1. We can also represent this with our variable expressions also, with an hint that since it is an SOP, my original variable A has to be represented by 1 and my complementary variable is to be represented by 0. So this would be represented as A complementary and this is A, and here it is to be represented as B complementary, C complementary. Here it will be B complementary C. Here it will be B, C, and here it will be B and C complementary. And also we can designate our cells as 0, 1, 2, 3, 4, 5, 6 and 7. Now since the problem being given to me is in the symbolized form of cell designation, in place of those I have to fill up my K blocks in terms of 1 since it is SOP. So now I'll fill my K map with 1, and this is how it is been filled up in place of 0, in place of 2, in place of 3A1, in place of 4A1, in place of 5A1, in place of 6A1. So now the next task that comes to us is to find the groups. When we are forming a group, you may observe the K design and give a pause and guess that how many groups are possible with this K mapping. Do ensure that when a group is being done, we have to get the grouping as large as possible. So the largest group out here possible is with a group of 8. So ask this question to you, is group of 8 possibility is there or not? If no, then move on to the searching of possibility for 4. Is the group of 4 possibility is there or not? So while observing, you would see that a group of 4 is evident, and that is nothing but by the way of this. Then you check whether there is a group of 4 possible again, and it would be observed that no such is further possible. So next, look into whether the grouping of rest of the ones could be done with a pair, and you would observe that yes, the pairing would be done evidently with this. So you would observe that you have landed up with 3 groups. One group is nothing but G1, the other group is nothing but G2, and the next group is nothing but G3. So now let us look into my G1. When you look into your G1, now let us name the expression of this group. So when you look into this G1 group, you would see that it indicates or represents 2 rows, and these 2 rows have no binary or no variable in common. Then you will eventually look column wise. So you will look this column, you will look this column. So you would see here it is 0 0 and here it is 1 0. So if you just look into the binary form, you would see that the 0 and 0 is common. Or else if you just look into the expression that is up, that is B complementary, C complementary and B C complementary. Look into both and see whether there is any variable that is in common, and it is evident that there is one variable C complementary in common. Next, we would look into the group G2. So when I look into this group G2, it refers to a single row, that is 0. So since it is a single row, there is nothing to compare, so it is a complementary. Now look column wise also, you have 1 1 and you have 1 0. Or look into the expression up in terms of variable, it is BC and it is B complementary. So which variable seems to be common? And that is nothing but B. So the one which is common has to be put into account. So the expression for G2, or the naming of expression of G2 here, is A complementary B. Now look into your third grouping, and third grouping refers to the row 1. And now this A is a single where you cannot compare it, so it is nothing but A. And eventually look the column wise also, that is B complementary, C complementary and B complementary C. And here you will see that B complementary seems to be common. So now you would lead into the conclusion part of simplifying the given Boolean expression. And since it is in the form of SOP, then it would be written in the form of sum of products. So C complementary plus A complementary B plus A B complementary is the simplified form. So we observed that my output was C complementary plus A B complementary plus A complementary B. Now you are being asked to implement it with the gates. So now if I have to express this into my gates, then how should I do it? We need to first understand that it is in the form of SOP, that is sum of products. So when I represent this into the gate, then I have to first concentrate on the terms which are with the products. So I observe that there are three product terms. Three product terms. So when I talk about the three product terms, it means and. I can connect it with and these three are then summed up with or. So first I have to connect these with 3 and. The first one has only one input, say C, and it is C complementary. So when I say C complementary, it will go with the not, and hence the output that I get is C complementary. If I look into the next term, you would see that it is nothing but A and it is nothing but B complementary. So when would you get B complementary is when you pass this B with a NOT gate, and finally you get your output here to be A B complementary. And the third term represents A complementary. So if there is an input A, then it passes through the NOT gate and gives the output as A complementary, and there is an input B which finally when goes or passes by AND gate gives me the output A complementary B. So now these three product terms are now been summed up, and it is been summed up means you have to use the gate of OR, and it is nothing but represented in this way, giving you the output of Y as C complementary plus AB complementary plus A complementary B. So now we are supposed to connect it, and how would you connect? You would connect it as like this, and in this way. So finally the output which you get is nothing but Y is equal to C complementary plus AB complementary plus A bar B. If you would have noticed the question was to simplify the Boolean function using K-map in SOP and POS form. So now we have completed the solving in SOP form. Now let us look how would be the simplification when we consider the POS form. So in my SOP which was being given to me in the problem was f of a comma b comma c, that is summation of small m 0 comma 2 comma 3 comma 4 comma 5 comma 6. And now if I had to represent this into my POS form, then how would this be written as? In POS form, that is, it is the product with capital M and the missing cells have to be written. So if noticed, my missing cell here is nothing but 1 and 7. So now for this we need to find out the simplified Boolean expression using K-map. So now since it is identified with your 3 variable, the K-map would be drawn with 8 blocks or 8 cells, and also to be kept in our mind that since it is POS, that is the max term, then my A will be represented by 0 and the complementary would be represented by 1. So with this understanding, let us now form our K-map design. So now when I form my K-map design, I have to be very conscious with my understanding that the base of the problem was SOP and I go with the base, right? And here it is A variable, BC variable 0 0 0 1 1 1 1 0. Here it is 0, here it is 1. But you have to keep it in your mind that the problem that is being given to you is in SOP form only. So with this given backup only, we need to find out our POS. So in my SOP, my A is being represented by 1 and A complementary is represented by 0. So we would now designate this A to be nothing but A complementary and this 1 to be nothing but A, and here it is nothing but B complementary, C complementary, B complementary C, here it is B C, here it is B C complementary, and this is how the cells are being designated as 0, 1, 2, 3, 4, 5, 6 and 7. So now what we have to do is we need to fill this K map with 0 as we are supposed to find POS. So now when I say that it is 1 and 7, then the output would be placed in the form of cell 1, that is 1 here, and in 7 1 here. So as I have already said that since we are heading on with our POS form, I am a bit conscious that the K cell that is being designed, I am representing it by 0 because this value is been represented for product of M, so it is for POS. So I fill up my K map with 0 only. So now if I just look into that, how should I happen to group it? It is well observed that I cannot group it as octant, I cannot group it as a quad, even the possibility of pairing is also not observed. So the only way where I can group would be individually. So I consider this as a group and I consider this as another group. So now when I just look into how I am going to name this group, I would see that this represents to a single row, that is A complementary, and it represents to a single column as B complementary C. In the same way, if you just look into your G2 grouping, it represents to a single row, that is A, and to the single column it is BC. So the output for this would be in the form of Y is equal to A complementary B complementary C plus A B C. But it is to be noted that I have written in the form of SOP. But you have to be very mindful in converting into POS, and that is nothing but Y is equal to A plus B plus C complementary into A complementary plus B complementary plus C complementary. So this is nothing but the POS expression. And now we have to convert this expression into gates. So now I would see that the POS that was been given or simplified was in the form of A plus B plus C complementary into A complementary plus B complementary plus C complementary, and the gate expression would be to be understood that there are two gates to be first denoted in terms of sum and then connected with AND. So now I introduce to you the sum gates, the next sum gates. So this is the OR gate where we see the input as A, B and C complementary. So For this C complementary, it passes through the NOT gate. And similarly, here it is A complementary, B complementary and C complementary. So my input A would pass through the NOT gate, my B will also pass through the NOT gate, and my C will also pass through my NOT gate, and this will give me the output A plus B plus C complementary, and here this will give me the complementary the output as A complementary plus B complementary plus C complementary, and these two are connected by the symbol AND. So I would have the symbol AND has this, giving me the output function as, say, f or y. In the problem it was being given as f or y, accordingly it has to be taken. So if it is been denoted by y, then here also we can denote it by y as A plus B plus C complementary into A complementary plus B complementary plus C complementary. So now this is how I will be connecting it to my AND gate. So I hope you would have got a clarity on how to simplify a Boolean function using K-map in SOP and POS form, and henceforth implementing it with the gates also. So here the thing to be noted is that you were being given the SOP form, and from the SOP form you had deduced your POS form. So in the next video, very exclusively, you would see a problem where you would be given a max term, and hence we will see that how using the max term the simplification with K-map could be done. Thank you.